Hi dear. Today we'll see a few reactions and few activities. Okay. So what type of reaction is taking place? Okay, we'll see here. Okay, burning of first one is your burning of coal. Coal means what? Your carbon. Okay, carbon in the form of solid. Burning means in the presence of oxygen only it can burn, right? This is O2. This is gas. Carbon plus oxygen, it gives carbon dioxide gas. Okay, so uh, two reactants combine to form one single product. Okay, so right, this is a example of what reaction? This is a combination reaction. Okay, this is an example for combination reaction. Likewise, formation of water from hydrogen gas and oxygen gas. Here it is balanced, right? Carbon, one carbon, oxygen. Okay, right. Okay, here formation of water from hydrogen gas and oxygen gas. Hydrogen H2 gas plus oxygen gas gives H2O. This is liquid, right? Water molecule, water. So here 2 oxygen is here in the reactant, here 1, so we'll make it to 2 here. Then this hydrogen became 4, so we'll put 2 here. Now it is balanced. Okay, hydrogen gas plus oxygen gas gives water, which is liquid, right? So it is again, it is an example for a combination reaction. So these two reactants combine to form a single product. So it is an example of combination reaction. Okay, next, burning of natural gas. You know natural gas formula? Natural gas is your methane. Okay, okay, methane. This natural gas is methane. Its formula is CH4. Okay, CH4. Burning of natural gas. Again, burning of natural gas means, so methane, CH4. This is gas. Burning occurs in the presence of oxygen, so this is also a gas to form. So when natural gas is burning, you will get carbon dioxide. Okay, carbon dioxide gas plus H2O. Okay, 2H2O. This is also in the form of vapor, so you can write it as gas. Okay, so one C is there, one C is there. Here 4 hydrogen in here, so we can make it to 4 here in the product side also. So now the oxygen becomes here 2, here 2, so 4 totally. So we'll make it to 4 here. So 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogen, and 4 oxygen, 4 oxygen totally. 2 plus 2, 4. Okay, okay. So what type of reaction it is? Here lot of energy, heat will be released. Okay, so it is a exothermic process. Plus heat, lot of heat will be released while burning, lot of heat will be released. So it is an example of an exothermic process. Exothermic process. Okay. Next one is your respiration process. Respiration means what? And breaking down of glucose in the presence of oxygen to get energy. Okay, to get energy is called respiration process. So glucose, you know the formula of glucose, right? What is the formula of glucose? C6H12O6. You remember? So this is a glucose formula, plus in the presence of oxygen, you need oxygen to break down. So glucose plus oxygen gives CO2. You will be releasing carbon dioxide plus H2O, plus lot of energy is produced, right? Energy is produced, energy is released. So C here 6 C is there, so we will make it to 6 CO2 becomes 12. 12 plus 2, first we'll balance here. Already how many hydrogens are 12 here, so we'll make it to 12 here. Here also 12 hydrogen. How many oxygen are present here? Here 6 plus 2 8 here. Here already 12 is present here, so 12 plus 6 18. So we'll make it to 6 to the 12 plus 6 18. Here 18 oxygen, here also 6 to the 12 plus 6 8. Okay, so now it is balanced. Okay, so C6H12O6 plus 6 CO2 gives 6 CO2 plus 6 H2O plus lot of energy. Lot of energy is released means it is an example. Respiration is an example of exothermic process. Okay, because lot of energy will be released when respiration is taking place. Okay, right? Respiration process is taking place. Okay, next. So this everything is in the form of aqueous state. Aqueous state. Here carbon dioxide is also in the aqueous form. This is liquid water. Okay, next, decomposition of vegetable matter into compost. So vegetable matters, okay, by the microbes or small insects, everything involved in this. Vegetable matter will convert into compost plus lot of heat will be produced, okay, along with so many products. Compost plus carbon dioxide plus H2A, so many things will be released from this. So lot of heat energy will be released. For example, if you keep some vegetables in a fridge, and if you switch off the fridge means after 2 days if you open this, you can feel the heat. Because of the decomposition of the vegetable matter, you will get a heat. Lot of heat will be produced in the decomposition reaction. Okay, decomposition of vegetable matter by the microbes. That is what one single product is breakdown into so many things: compost plus heat plus carbon dioxide plus H2S, so many things, ammonia, etc. Okay, that's why it is called decomposition. Decomposition means what? Breaking down of single reactant into so many products, simpler products. Okay, so this is your example of decomposition reaction, and also this is an example of exothermic reaction. Okay, it is an example of decomposition reaction, and it is exothermic in nature because lot of heat energy is released. Exothermic in nature. Okay, next your activity 1.5. So take about 2 grams of ferrous sulfate crystals. Okay, they mentioned ferrous sulfate crystals in a dry boiling tube. Note the color. Heat the boiling tube over the flame of a burner. Okay, so first we'll write the equation. What is meant by ferrous sulfate crystal? Ferrous sulfate crystals means it is a hydrated salt. It contains water over it. Okay, FeSO4 7H2O. Okay, so upon heating, first note this. They asked us note the color, right? So the color of the ferrous sulfate crystals is light green in color. Okay, light green in color. Upon heating, it will release this water. So it will be separated. It gives a colorless FeSO4. This is colorless. Sorry, not colorless, white color. So light green changes into white color, ferrous sulfate plus 7H2O. Okay, and further heating this ferrous sulfate, the ferrous sulfate will convert into ferric oxide, Fe2O3 ferric oxide plus sulfur dioxide plus sulfur trioxide. Okay, okay, it is already balanced. I already balanced this one. So this ferric oxide plus ferric sulfur dioxide plus sulfur trioxide will be released. Okay, so what is your observation from this activity is, when you heat this, first the water from the salt, the crystals water from the FeSO4 7H2O will be first removed. That water vapor condense inside the test tube itself. So it means what? If you heat the test tube, you are having the ferrous sulfate here. The water vapor will come here and it will be condensed here in the sides of the tube itself. If you are doing this experiment, you can see that the water droplets will be in the sides of the test tube. Okay, so water vapor condense inside the test tube. The color change from green color to reddish brown. Upon heating this, the ferric oxide, right, this is reddish brown in color. Reddish brown in color. Then what other observation? Then you can smell the burning sulfur, right? So this sulfur dioxide is produced, right? Gas, no. This smells, you can feel the smell. This burning of the sulfur will be like the burning of the matchstick, no? If you burn the matchstick, you will get some smell, no? That smell, that is the burning of the sulfur. Okay, and this one is this is odorless and colorless. So sulfur trioxide is. Sulfur dioxide, you will get the smell. Don't inhale it directly. You can smell this wafting smell. So you should not bring the test tube nearer to your nose. You have to keep it away from your nose. Okay, I'll see one second. See, this is your activity 1.5. You have to hold the boiling tube like this with the ferrous sulfate crystals. Once you burn, point the mouth away from your point the mouth of the boiling tube away from your mouth, so that you will get this wafting gas gently towards the nose. You can have this. Okay, don't inhale directly. Okay, so you can get the wafting gas. Okay, so it smells like the burning matchstick. Okay, so this is your experiment. Okay, so when ferrous sulfate crystals are heated, first it releases the water from that ferrous sulfate. Hydrated ferrous sulfate become anhydrous. Okay, so FeSO4 plus 7H2O will be formed. Then upon heating further, you will get the ferrous sulfate will changes to ferric oxide plus SO2 plus SO3. Okay, the ferric oxide color is reddish brown in color. Okay, then so this reaction takes place in the presence of heat, and also the single product is split into so many single reactant is split into so many products. Okay, so it is an example of thermal decomposition because it happens in the presence of heat. Okay, and also it consumes energy, right? So it consumes heat energy for this reaction. So it is an example of endothermic reaction. Okay, it's a thermal example of thermal decomposition, as well as based on the temperature, it is a endothermic reaction. Okay, and next one is decomposition of calcium carbonate. What is the formula? First we will write the formula. What is calcium carbonate? CaCO3, calcium carbonate. This is solid. The common name for this calcium carbonate is limestone. Decomposes means when you heat this in the presence of heat, it decomposes to form calcium oxide plus carbon dioxide. Okay, calcium oxide plus carbon dioxide. This is your solid. Calcium oxide is nothing but a quicklime. and this is your gas. Okay, so you know this uses of this calcium oxide. It's used for whitewashing and also for manufacture of cements. Okay, white cement. um, so again, the single reactant is decomposed to form two products. Okay, so it is an example of what reaction? Decomposition reaction. Decomposition reaction, and also it involves heat, hence it is called thermal decomposition. Okay, this is called thermal decomposition reaction. Next activity 1.6. So take about 2 gram lead nitrate powder in a boiling tube, hold it with a pair of tongs and heat it over a flame. Okay, first we'll write the equation formulas and all. Okay, lead nitrate formula, PbNO3 twice, it is a solid. Okay, solid crystals. While heating it becomes lead oxide. Lead oxide plus nitrogen dioxide plus oxygen will be produced. Okay, so if you this lead nitrate this lead nitrate is white crystals. It is in the form of a white crystals. Upon heating, you will get a lead oxide, which is yellowish in color. Yellow in color. Okay, yellow in color. And while heating, you will get a dense brown fumes. Okay, that is because of nitrogen dioxide. This you will get it as a brown fumes. Okay. So while if you heat this lead nitrate, brown thick dense fumes will be coming out, that is your nitrogen dioxide, and you will get a residue in the test tube, that is yellowish, that is your lead oxide. Clear on this? Okay, so what is your observation? Brown colored vapors come out, that is fumes of nitrogen dioxide. Next, lead nitrate, which is so white crystals. The color is white in color, and it is in the crystal form, turns to yellowish lead oxide. Okay, so again it taking place in the presence of heat, and one single reactant is converted into so many products. So it is an example of thermal decomposition. Okay, thermal decomposition, and it involves the it requires heat to decompose. So it requires heat means then it is an endothermic reaction. It is an example of endothermic reaction. Clear? Thank you.